All right, we're going to look at one last example of a translation, and this time we're going to be subtracting 2 from the input. So I want us to think for a moment what's going to happen here. Remember before when we saw adding 2 to the input, we saw shift 2 to the left. So sort of in the opposite direction of what was happening, although when we did it to the output, we saw a shift 2 up. So it did sort of act the way we expected it to act. So let's see when we subtract 2 from the input. What do we think this is going to look like? Well, first let's just get a reminder on how this h of x being the square root of x works. Right? When we try to take the square root of -1, in our real number system it's going to be undefined because it would be I, and that's just not something we're going to mess around with. So we're just going to call this undefined since we're working in our real number system. When we take the square root of 0, that would be 0. When we take the square root of 1, that would be 1. When we take the square root of 2, we get kind of a yucky number, right? Some yucky decimal that we're not going to try to worry about evaluating here. Same thing for the square root of 3. An icky long decimal, it's irrational, so we're not going to worry about it. Square root of 4 is no big deal for us, right? That's just 2. And the next sort of nice one that we have would be the square root of 9. So, how are these going to shift around the coordinate plane if we subtract 2 from x before we take the square root? Right? So this h of x minus 2 would be the square root of x minus 2. So we're subtracting 2 before we take the square root. What that means for us is that when we input -1, we would actually end up with the square root of -1 minus 2. -1 minus 2 would be -3. So that would be A, imaginary, and B, just kind of icky on top of being imaginary. So we're not going to worry about that one. The same thing with the square root of 0, which before had a nice definition, right? When our input was 0, we had the square root of 0, which is 0. Now when our input is 0, we have 0 minus 2, so we would have the square root of -2. So again, that's going to be an undefined value for us. When we input 1, we would have the square root of -1. Again, that would be undefined for us. When we input 2, now we'd have the square root of 2 minus 2, which would be the square root of 0. And that's just 0. So notice that before we were inputting 0 to get 0. Now we're inputting 2 to get 0. So our input of 2 gave us 0. Right? When we input 3, we get the square root of 3 minus 2, which is 1. The square root of 1 is just 1. So when our input's 3, we get 1. 4, we would have the square root of 2, right? Because it would be 4 minus 2. That's icky again. 5 would be the square root of 3. That's icky again. 6 would be the square root of 4, and that comes out to good old-fashioned 2. So now we're at 0, 1, 2, 3, 4, 5, 6, giving us an output of 2. And we can start to get a feel for what's happened here. Right? Our whole graph, our whole function, has shifted to the right by 2. Shift right by 2. So just to get a quick review, when we subtract 2 to the inside, it shifts right. When we subtract 2 to the input, it shifts to the right. When we added 2 to the input, it shifts left. Right? So we usually think of positive being to the right, but what's going to happen is it's going to shift the graph to the left. When we add to the outside, it shifts up, and I'll just go ahead and kind of spoiler alert here. If you subtract to the outside, guess which direction it would shift? If you said down, high five.